Okay, picture this. You're sitting in a quiet room, the air is tense, and across from you sits an MEO Class 4 surveyor. They cross their arms, look you dead in the eye, and ask a question that sounds deceptively simple, but actually has about a dozen different ways to trip you up. If you've ever felt the sheer panic of preparing for that exact moment, well, you are definitely in the right place. Welcome to this explainer. Today, we're handing you the ultimate high-yield cheat sheet to not just survive, but absolutely master the surveyor's interrogation. And the best part? Everything we're covering today is drawn straight from the meticulously detailed, handwritten notes of Cadet Tabish Syed, so we are diving directly into authentic, battle-tested study material. No fluff, we are perfectly distilling some highly complex maritime regulations into exactly what you need to remember so you can answer clearly, confidently, and properly when the pressure's really on. All right, let's quickly look at our syllabus for conquering this oral exam. We are going to cover essential maritime safety regulations, fixed firefighting systems, steering and door operations, load lines and freeboard defined, and finally, understanding ship bulkhead types. Okay, kicking things right off with Section 1, Essential Maritime Safety Regulations. Now, a seasoned surveyor is almost always going to start broad before they start digging into the granular details. They'll lean in and ask, Cadet, what is the core purpose of the ISM code? This is such a common opening exam question, and yet you'd be surprised how easily it gets fumbled. It's broad enough that a nervous cadet might just start rambling, but we're going to give them exactly what they want to hear. See, the surveyor isn't looking for a rambling paragraph. They want precise, punchy points to prove you grasp the structural intent of the International Safety Management Code. You hit them with these exact objectives: ensure safety at sea, prevent human injury or loss of life, avoid damage to the environment and property, establish safety management systems, and clearly define the responsibilities for the master and the designated person ashore. Boom, you've set the tone, you know your stuff. Moving right along to Section 2, Fixed Firefighting Systems. So, transitioning down into the ship's emergency systems, this is an area where surveyors demand absolute unforgiving precision, mainly because lives literally depend on it. Now, surveyors absolutely love to ask compare and contrast questions. It tests two sets of knowledge at once, right? And asking for the difference between high-pressure and low-pressure CO2 systems, man, that is one of their biggest hitters. This brilliantly illustrates the exact contrasts you need to verbalize. But here's the trick. Don't just list facts, you have to connect them. Explain that high pressure operates above 100 bar, which allows for smaller, lighter cylinders, which then results in a rapid discharge rate of 30 to 60 seconds. Conversely, low pressure operates below 100 bar, requiring larger tanks and a slower discharge of 1 to 3 minutes. Show them you understand exactly how the pressure dictates the physical storage and the response time. And when you're talking about high pressure CO2, the surveyor is waiting to hear this one specific number, 250 bar. You must clearly state the 10-year maintenance routine. 10% of CO2 bottles must be pressure tested at exactly 250 bar. But here is the absolute crucial detail. If even one of those bottles fails that test, every single bottle in the entire system gets tested, no exceptions. Now, looking right at the notes for the hypermist system, we see the answer to a classic trick question. The surveyor will ask, hey, you have an ocean of water around you. Why must the hypermist use fresh water instead of seawater? The answer needs to be immediate. Seawater is highly corrosive, and it will rapidly choke and damage the very fine nozzles required to create the water fog. It really is that simple, but they will try to catch you off guard with it. All right, jumping into Section 3, Steering and Door Operations. Look, if you can't steer or you can't seal the hull, you don't have a safe ship, period. Let's say the surveyor brings up steering gear on a tanker. The number you need locked in your brain is 10,000 GRT, or gross registered tonnage. This is the magic threshold. According to SOLAS, Regulation 29, any tanker of 10,000 GRT and above must strictly comprise 2 or more identical power units for the main steering gear. It's a completely non-negotiable redundancy standard. So the real takeaway here is memorizing these exact seconds and angles. You gotta deliver these numbers like a rapid-fire drill. Main steering, 35 degrees one side to 30 degrees the other in under 28 seconds at max ahead speed. Auxiliary, 15 degrees to 15 degrees in 60 seconds. Power failure, control must be regained in no more than 45 seconds. In the surveyor's eyes, saying something like around 30 seconds is a fail. You need to say 28 seconds. That exactness proves your competence. Next up, the surveyor throws out another classic trap question that constantly trips up cadets. Explain the difference between a watertight and a weathertight door. They sound super similar, right? But confusing them out on a ship could literally result in a catastrophic sinking. What's really interesting is how this simplifies the concept into just a matter of pressure direction. Watertight doors, which you usually find lower down in places like the engine room, must withstand immense water pressure from both sides to prevent continuous flooding if submerged. Weathertight doors, found way up on the deck, only need to withstand water pressure from one side, primarily from standing waves crashing over the deck during heavy weather. Section 4. Load lines and freeboard to front. Transitioning outside the hull, this is all about how a vessel legally and safely sits in the water, ensuring it has enough reserve buoyancy. Now, when asked to define freeboard, do not paraphrase. Actually, scratch that. Don't try to wing this one at all. The surveyor wants the exact textbook phrasing for core stability concepts. You tell them, freeboard is the distance from the waterline to the top of the deck plating at the side of the deck amidship. Say it with complete confidence. And check out the specific dimensions for the load line mark, often called the plimsoll line. You have to know these physical details. The ring is exactly 300 millimeters in diameter. The horizontal line passing right through it is 450 millimeters long, and every single line is exactly 25 millimeters thick. Knowing microscopic details like this proves to this surveyor that you don't just understand the abstract concept, you know the actual physical reality painted on the side of the hull. From there, you'll definitely need to distinguish between freeboard types. Just explain how a ship's fundamental cargo purpose dictates its deck structure. For example, a Type A ship carries liquid cargo, has a continuous weather deck with small openings, and super high structural integrity. Type B is for dry cargo, so it features a discontinuous deck with much larger hatch openings. Basically, the physical structure dictates the freeboard type assigned. And finally, Section 5, Understanding Ship Bulkhead Types. Okay, this is often the most structurally complex portion of the whole exam. Internal partitioning and fire containment. The surveyor sits back. This is the ultimate stress test. They ask what are the specific temperature criteria and times for Class A, B, and C fire bulkheads. This requires you to recall multiple data points simultaneously without getting them mixed up. But look how organizing this data visually builds the perfect mental framework. Just look for the pattern. Both Class A and B must restrict the maximum average temperature rise to 140 degrees Celsius on the unexposed side. But Class A has to hold that for 60 minutes, while Class B is only 30 minutes. The joint temperatures vary slightly too, 180 degrees versus 225 degrees. And Class C? Well, it just needs to be non-combustible. There are 0 specific temperature rise requirements. Just visualize this grid and you absolutely cannot fail the question. We have one final structural metric to memorize, the collision bulkhead. You must state that it has to be located not less than 5% of the ship's length or 10 meters, whichever is lesser. You just explain that the extreme bow of the ship literally needs this specific crumple zone protection in case of a head-on impact, keeping the rest of the vessel completely watertight. So the surveyor puts down their pen, they look at you, and you know what? You didn't just guess. You delivered the exact numbers, the precise definitions, and the structural reasoning behind every single thing you said. Because you understood exactly how to structure your knowledge, drawn straight from these detailed cadet notes. That interrogation wasn't a trap at all. It was basically an opportunity to show off exactly what you know. So review the facts, lock in those numbers, and ask yourself, are you ready to pass? Thanks for joining us on this explainer, and we will catch you next time.